Hello folks, today in this video I'd like to talk about solubility in electrolytes. We're going to be able to predict whether a substance is soluble, we're going to be able to identify acids and bases, we're going to be predicting whether a substance is a strong, weak, or non-electrolyte, and then finally we're going to be talking about different solutions and how we should look at the molarity of those solutions. So let's dive right in. Well, first off, let's talk about what solubility actually means. Well, if you take a solution or a beaker and imagine like taking NaCl and putting it in water, you'll know that, of course, you'll see those little salt crystals in the bottom, and eventually they'll go away. Now, they didn't just disappear. They're still in the beaker, but they are solvated, or they are soluble. They're dissolved in the water. They're kind of all mixed throughout. So solubility refers to creating a solution, a homogeneous mixture, where those molecules of the solvent have completely dissolved your solute, and so they are completely mixed together. This works for ionic compounds like NaCl, and it works for covalent compounds like sugar. You can take sugar and, of course, dissolve it in water as well. But not all compounds are soluble, and there are some rules you want to know for determining whether something's soluble or not. When it comes to an ionic compound, remember, ionic compounds are metals and nonmetals, there is just a chart, I'll call it the solubility chart, that you would want to look at. You might remember using a solubility chart in a previous chemistry class and like a reference table. We have one in AP Chemistry in our AP Chem textbook. I find it pretty useful. This is a picture of what it looks like here. And it just gives you some guidelines of what is and is not soluble. Everything in this column here, these are all soluble anions, and these here are generally insoluble, of course, with some exceptions to both. Now, this would be a lot to memorize. You do not need to memorize all of this chart as well. However, for AP Chemistry, there are 3 solubility rules you do need to know. Those 3 solubility rules, you'll notice that there's a common exception here, that the alkali metal cations are soluble. So our rule is that all group 1 metal ions, so that's things like lithium, sodium, potassium, those are soluble. So any compound, ionic compound that contains one of the group 1 metals is indeed soluble. Another rule you want to have memorized is that all nitrates, NO3-, are soluble. So potassium nitrate or calcium nitrate or any nitrate compound is soluble. And then lastly, all ammonium compounds, NH4+, are soluble as well. You'll notice that's a common exception here for those as well. So those 3 things you got to memorize. The rest of this chart, if you ever needed it, it would be given to you on a test. So that's how you figure out if an ionic compound is soluble. Well, how do you know if a covalent compound is soluble? How do I know that sugar is soluble? Well, you might remember kind of a rule of thumb you can use. That rule of thumb is that like dissolves like. Now, what does that mean? That means that compounds like sugar and water of similar polarity are soluble. So you might recall that water is a polar molecule and sugar is also a polar molecule. So because sugar is polar and water is polar, they will dissolve in each other. Whereas oil is nonpolar. So if you try to put oil in water, they won't mix because they don't have similar polarity, which has to deal with their intermolecular forces. Okay, so that's how you figure out if something's soluble. How do you determine if something's an electrolyte then? Being an electrolyte is related to solubility, but is a little bit different. You have to be soluble to be an electrolyte. But what an electrolyte does is a substance. So it's a compound that produces ions in solution. And because it makes ions in solution, it conducts electricity or conducts electrons, because you know ions are charges and electricity is carried through moving charges. So going back down to our example here with the salt and the sugar, you can see that when the salt, it's an ionic compound, dissolves in water, I can clearly see positive and negative ions. So that is going to be an electrolyte because it creates these ions in solution. Sugar, even though it dissolved in water, there's no ions there. It's just molecules of sugar kind of all spread around the beaker. So that is not going to conduct electricity. That would be a non-electrolyte solution. So heading back up here, How do you tell if an ionic compound is an electrolyte? Well, the rule is super simple. If it's soluble, it is an electrolyte. So ionic compounds, because they're made of ions, if it's soluble, it's going to be an electrolyte for sure. So that's a nice, easy rule. Covalent compounds, on the other hand, are a little bit trickier. They are generally non-electrolytes. So even if they are soluble, which not all of them are, generally they are non-electrolytes. However, there is a huge exception to this. And you want to know the exception? The exception is acids and bases. Acids and bases can be covalent compounds that are indeed electrolytes. So let's talk then about how do you know whether something's an acid or a base, and how would you figure that out? So an acid, kind of by definition, produces H plus ions in solution. So let's take a really common acid, HCl, you might have heard of before, hydrochloric acid. If you take HCl and put it in water, that HCl will split up into H plus and Cl minus. So we can kind of see that, oh, yeah, that indeed is going to be an electrolyte, because even though it's covalent, it's going to be soluble because it's polar, but I might be, it might not, conduct electricity. You'd be right if it wasn't an acid, but because it makes H plus and Cl minus, it is an acid. Now, how you can tell if something is an acid, it generally starts with H in the front of the chemical formula. Bases. Bases produce OH minus ions in solution. So a common base, for example, would be NaOH. Now you notice that's an ionic compound, and all we'd have to know to figure out if it was, an electrolyte would be, is it soluble? Well, NaOH is indeed soluble, and all Na group 1 compounds are soluble, and it makes Na plus and OH minus in solution. So yeah, okay, that makes sense. That would indeed be an electrolyte. Bases then typically they typically end in OH. So you'll see an OH at the end of a base. Now, there is a big difference, though, between what are called strong acids and bases and weak acids and bases. So that's our next chart to take a look at here. Down at the bottom, I've got a table of the strong acids and bases. This is unfortunately something you're going to want to memorize. There are 7 strong acids listed here, but actually, I'm not too concerned if you have the chloric acid memorized. Don't worry about HClO3. Just go with the other 6. The reason is chloric acid is kind of on the line between strong and weak, so we're just going to consider it weak, and we'll just memorize those 6. So HCl, HBrHI, HClO4, HNO3, and H2SO4. Then for the strong bases, like I said, they're the soluble hydroxides. So it makes sense. We memorize that all group 1 ions are soluble. So boom, all the group 1 metal hydroxides. And there are 3 more: calcium, strontium, and barium. So if you're looking at the periodic table, it's group 1, and then calcium, strontium, barium. They are soluble, and therefore they are strong bases as well. Now, why is this important? Well, because strong acids and bases what makes them different is they completely ionize in solution. So if you put HCl in a beaker, all of the HCl is going to break up into H plus and Cl minus. There's going to be no HCl left over. And so because of that, they are very strong electrolytes. So they conduct electricity very well. Whereas the weak acids and bases, they don't break up in solution very well. So they only partially ionize. A good example of a weak acid or a weak base is acetic acid, vinegar. Vinegar, CH3COOH, is an acid, but it doesn't really ionize. If you have a bottle of vinegar, most of the vinegar is still CH3COOH. It hasn't broken up into H plus and CH3COO minus. In fact, we would describe this not as an completion reaction, but in equilibrium. And so because of that, they make what we call weak electrolytes. They conduct a little bit of electricity, but they wouldn't be very good at it. Now, how do you tell whether something is strong or weak? Ultimately, there's a reason I'm having you memorize the strong acids and strong bases, because if it's not one of those, it is by definition weak. Any acid that is not on that list is a weak acid. Any base that's not on that list is a weak or a weak base. So the common ones you're going to see for the weak acids, any particular polyatomic ion like nitrite. So if you see HNO2, because that's not on the list, it's going to be a weak base. So anything with H in front of it there. And organic acids. So anything that ends in COOH, remember this is an organic acid, and those will also be weak. For the weak bases, there's honestly not many that you're going to see, except for one that comes up all the time. That is NH3, ammonia. Ammonia is a weak base for sure, or sometimes you'll see some carbon compound with NH2. Those are called amines. And like ammonia, they are indeed weak bases. So when you see weak acids and weak bases, those are kind of the common ones you'll see, and you'll know that they do not completely ionize. Okay, let's make a summary of all this because there's a lot to unpack there. So in general, you've got 3 different types of electrolytes. You've got strong, you've got weak, and you've got non. The definition of a strong electrolyte is that it creates or completely ionizes in solution. And the examples of a strong electrolyte are soluble ionic compounds. So any ionic compound that is soluble is a strong electrolyte, as well as the strong acids. There are 6 that you got to memorize, and the strong bases, which are the hydroxides of the group 1 metals, and then calcium, strontium, barium. And that's it. For weak electrolytes, those are going to only partially ionize. And the only thing that are weak electrolytes are the weak acids, like organic acids, and weak bases, like ammonia or the amines. So those are the only thing that are going to be weak. And then finally, non-electrolytes do not contain ions. And so our non-electrolytes, those are things like insoluble, ionic compounds, or molecular or covalent compounds, except, of course, for acids and bases. So covalent compounds. Apologize there. And so that's how you figure out. You want to figure out which one of these things a compound is, and that's how you determine whether it's strong, weak, or not. If it's a soluble ionic compound, it's strong. If it's a weak base, it's weak. If it's a covalent compound, it is a non-electrolyte. Okay, one last thing here. If you're looking at, for example, an ionic compound, you might get some questions that ask you about specifically the molarity or concentration of a particular ion in that compound. This is related to the molarity stuff we have done previously, and it's pretty simple. If you've got 1.5 molar FeNO33, it's asking you, well, what is the concentration of the nitrate ion in FeNO33? Well, we can make a little chemical equation showing that if you put this in water, it's going to dissolve and break up into Fe3+, and there are 3 NO3 minuses. So I can make a little chemical equation and then relate the two. If you've got 1.5 molar FeNO3, I hope it's kind of obvious that, well, for every 1 FeNO3 you have, there are 3 NO3 minuses. And so your molarity would just be 4.5 molar. There's 1.5 molar of this, so there's 3 times that amount of nitrate. Next, I'd like to talk about what the total concentration of ions is in 2 molar Na2SO4. So here, similar to above, we have to figure out the total ion concentration. To get that, of course, you have to count the number of ions in Na2SO4. Well, obviously Na2SO4 is going to break up into 2 Na pluses and 1 SO4 2 minus. And so there are 3 total ions. So I could just simply take the 2.0 molar, multiply by 3, and my total ion concentration would be 6 molar. This last one just says to rank the following from lowest to highest ion concentration in aqueous solution. So here, similar to above, I've got 2 ions here. So my effective ion concentration would be 2. Here, I've also got 2 ions, potassium and chloride. So since it's a 2 molar solution, there would be 4 molar ion concentration there. For this one, it looks like it's a lot less, just 0.5, but there are 3 ions, 1 calcium and 2 nitrates. And so this one would, I'd have to multiply by 3, have an ion concentration of 1.5. And then finally, HCl, even though it doesn't look like it would be an ionic compound, it's covalent, it is indeed a strong acid. And so this would break up and make 3.0 molar because there is an H plus and a Cl minus ion. So I would rank this one from, it says lowest to highest. So the lowest would be this one. My second lowest would be that one. Third, and then finally the highest concentration would be that. Okay, folks, that's been a video about ion concentrations and solubility and electrolytes. Thank you guys so much. Have a great day.